This episode of Fluid Power Forum is sponsored by Endeavor AI. Endeavor AI automates order entry, quoting, and the quote-to-cash process. Win more, sell more, and save time, all without adding headcount. Head to endeavor.ai to learn more. This episode of Fluid Power Forum is also sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of the show, you can follow us on LinkedIn. You'll find us there at the National Fluid Power Association. Get plenty of updates on the show and other activities there. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, just share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to the show. You can find us on Apple Podcasts. We're on Spotify. We're on all the other popular podcatching services. Wherever you find us, go ahead, subscribe to the show, and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. On today's show, my guest is Ehren Polheber, a corporate fluid power engineer at Scott Forge. Founded in 1893, Scott Forge has been forging, ring rolling, heat treating, machining, and testing for over 130 years. And Ehren is joining us today to discuss material science and selection, as well as forgings and castings, and how they can optimize your fluid power system at its most foundational level. So Ehren, welcome to Fluid Power Forum.
Thanks, Eric, so much. It's an absolute privilege and honor to be here today chatting with you. Thank you so much for this opportunity.
You're welcome. I'm looking forward to the conversation, and I know you have an interesting background when it comes to fluid power. So maybe we can start there. Tell our listeners a little bit more about yourself and how you found yourself at Scott Forge.
Sure. So I've been in the fluid power industry I did the math, about 22 years. Right. Pretty much starting high school with fluid power introduction. So I started out entry-level mechanic helper on heavy equipment. I had the luxury of having a family of construction business in the family, and so I worked there from an early age. Helped out the mechanics there, really got a feel for really what I wanted to do, and I knew right away it was fluid power. Went to MSOE, worked myself to lab manager there at the Fluid Power Institute. And for the last exactly 14 years to the day, I've been here at Scott Forge as the corporate fluid power engineer, where we, in the engineering group, we design, build, and troubleshoot the largest forging and manipulating equipment in the world.
So today is your anniversary at Scott Forge? Tell us more about Scott Forge and what it does. I gave a little bit of an introduction there, but tell us more about the company.
Okay, so Scott Forge is 100% employee owned. We serve all markets with any kind of metal components in them, all the way from the part that fixed the Deepwater Horizon BP oil spill to the wheels on the Mars rover, everything in between. Some of our customers include CAT, Komatsu, SpaceX, Blue Origin, NASA, Department of Defense, Department of Energy. The list goes on and on and on. Literally, if there's something metal and it's big and heavy, we've probably been having conversations with those customers.
Yeah. Do you have a unique definition of fluid power? I'm just curious, like how much of your focus is on fluid power products?
Fluid power products is kind of unique for us. We don't really know 100% where they go. So some of our customers like CAT, Komatsu, some of those things might end up as cylinders or cylinder rods or something like that. So we're not 100% sure entirely, but probably on the order of 8 to 10%.
Okay. That's a pretty large percentage, it sounds like.
Yeah.
Yeah, and you've clearly got the background in fluid power to better understand how these materials are going to be best used.
Yeah, absolutely.
Yeah. Well, let's start at a high level and tell us, as I said in the intro, we want to talk about materials science and material selection. Why is that an important thing for us to be talking about? What difference does it make? What materials people make these things out of?
Yeah, okay, great. So material selection is super important in hydraulic systems, as you can imagine. Usually there are very high loads involved with hydraulic systems,
Sure.
and incorrectly specified materials along with heat treatments can be catastrophic on that larger equipment. It's not like it used, as something small, you might say, oh, I'll use a 1/4 inch plate there, I'll use a, 1/8 inch sheet metal there. And the fluid power stuff, since it's such a high forces, no, are we using a 9 inch plate there, or are we using a 12 inch plate there?
Right.
So mobile equipment, weight is usually a major design criteria. So using different grades of material can allow to keep, that strength high and weight down for those more critical weight savings opportunities.
Right. So is there a process that people have to go through to decide what materials they're going to use? What are some key parts of that process?
Yeah, absolutely, absolutely. So for me, several key considerations for choosing an appropriate material for a fluid power system specific. One, all applied loads on the machine and component, right? So we have to know is the forces are very high,
Mm-hmm.
and that, so we have to keep that in mind. Two, operating condition. So is this a high fatigue loaded thing? Is this fully reversing loading? Is it just a static base loading? Gravity only? Are temperatures high or low? Is it in a corrosive environment? Things like that. So
Yeah.
it all kind of plays in. Three, trade-offs. So do you need a high strength, or do you need a high strength at a high temperature? Does the material need to survive in a corrosive environment? Maybe it doesn't, maybe you can get away with some different grades that are easy to machine, but still have good, strong specs about them.
Right.
And cost. So obviously, it all comes down to cost. So, and all these things come at a cost, and they're all in balance with each other.
Yeah.
As materials evolve, so do the critical applications that require their use. Maybe what some old timers use as their flagship materials for a given application might not be the best anymore, or it was the best at the time, and now there are other options out there that have been developed to cut costs when higher strength isn't required, for
Sure.
example.
Well, it occurs to me as you talk through that, Ehren, that the manufacturer of the fluid power component probably, but maybe not always knows where the products are going to be used, and on what machine and in what application the products are being used makes a big difference on some of the variables that you just described, right? Right.
Yes, absolutely, absolutely.
Do you see that with? I mean, so you're selling your products are being sold when we're talking about fluid power. They go right into the fluid power component manufacturing business, I would assume, right?
Yeah, yeah.
And so, like, is your customer, ordering different kinds of materials for basically the same product based on where it's going to go in its destination, or are you not experiencing that kind of variability in the orders?
Oh no, there absolutely is variability. And the other
Yeah.
thing that we kind of pride ourselves on here at Scott Forge, we don't really sell forgings. We sell an experience, and we sell value, and we create that value by working with the customers. Like, hey, sometimes we'll just get a drawing from a customer, for Caterpillar example, or
Yeah.
whoever, and we might say, what does this bolt up to, or what is this going? Give us a little more of the story.
Right.
And it's very common that we combine multiple pieces into a single piece, and then that makes their life easier. We understand it better. We work together to select those materials as well. Like, hey, maybe we can get away. We can make this a little thinner, makes it a little lighter for your haul truck, and it becomes a win-win for both
Sure.
parties.
Well, let's talk about what some of these options are. I mean, what are there? Like, how many different kinds of material are being sold into the fluid power industry?
There's oodles and oodles.
Yeah, more than you can name, right?
Yes, yes. I would say there's an infinite number of materials, seriously, all serving all kinds of specific and application-dependent needs. Like I mentioned a little bit earlier, some are strong at low temperatures, some are strong at high temperatures, some are both. Some get stronger with loading. So loading and unloading, actually cold work material stronger while it's in service.
Yeah.
Some are lightweight. It's truly endless. Some of these material families Might include steel, stainless steel, aluminum, nickel, titanium, copper.
Yeah.
Really amazing.
So you mentioned material grades. Maybe you can break that down a little bit more. Do they come in standard categories?
There are some basic families, some basic families for sure. So for example, on a particular grade of steel, there are hundreds of different carbon and iron chemistries that create a grade, we'll call quote unquote, for different applications, right? So, you've got high carbon, or you got the low carbon for that particular grade of steel. They each have the pros and cons, and it's up to the material selector, the engineer, to choose one that fits the application best.
So it sounds like, I often talk on the show with people, and it always comes down to it's a conversation between the provider and the customer to figure out what it is that they need. It sounds like this is the same kind of thing.
Yes, it absolutely is. Definitely the conversation that's had. The more the story that you get, like you get like I mentioned, you get a drawing and it's got a material specification on it. But then when you get to learn more of the story, you get to maybe there's a tour involved even, and people get to see and feel, and it's like, okay, this is what this is. This is good. It's definitely worthwhile.
Right. We'll continue with our guest in just a moment, but first I want to tell you about an opportunity to engage in the future of fluid power technology. Two of NFPA's most active committees are our two technology task forces. One focused on mobile applications of fluid power, the second on industrial applications. Each of these task forces work on a series of projects that help us better understand the technology trends in these sectors and help us develop the resources and connections that will be needed to keep fluid power positioned as an actuation technology of choice on both mobile and industrial platforms. The Mobile Task Force publishes a series of reports. Their latest was on ways to design more energy-efficient fluid power systems for mobile equipment with electrified prime movers. The Industrial Task Force also publishes reports. Their latest was on ways to minimize and prevent leaks in fluid power equipment. And they have also completed a year-long project that created an independent technology roadmap specifically for fluid power in industrial applications. All of these resources are accessible on our website at nfpa.com/technology reports. But more important is your ability to participate on and engage with the technology professionals that serve on these task forces. New working groups are forming now around the use of sensors and data analytics in fluid power systems, as well as many other cutting-edge technology advances. These task forces are a great example of NFPA's effective forum in action, with NFPA members across the supply chain and an increasing number of their OEM customers actively engaged in creating the technology strategies that help all of their businesses grow. To learn more and to get involved, contact me at elanke@nfpa.com. Well, you also mentioned cost of ownership as a major concern when making some of these decisions. Maybe you can talk a little bit more about that. How does price play into this? I'm assuming there's some long-term implications in terms of what you're paying for the material.
Yeah, absolutely. So, like, for example, you can't just choose the best material at everything, or maybe not, it gets you 90% of the things, but it costs a whole lot. So you have to. Yeah. It's definitely a major concern. Might be able to use titanium or Inconel for most applications, right? Those are pretty strong materials. Major overkill if you didn't need to save weight or be strong at high temperatures. So these two grades are also very expensive if your application is required in those operating characteristics. As far as the long-term implications, if you select a low carbon steel and exposed to salt water, it's going to rust out much quicker than a stainless steel, for example. So, and maybe that degradation happens in a month, and maybe it's 10 years. You might see it. So you might not know, and it's a real concern, and that's why it's nice to get the conversations going and learn more about the application other than what's on the drawing.
Sure. Well, I mean, that corrosive aspect of it is going to be a major concern for the fluid power manufacturers. I mean, it's you got to make sure that whatever you make your stuff out of doesn't leach into the fluid, right?
Absolutely.
Yeah. Well, what do you think the future looks like? Are there new technologies in this material science space that may benefit the fluid power component manufacturing process, or what do you think's happening next?
I think there's a lot going on. I actually know there's a lot going on.
Yeah.
Here at Scott Forge, we've built an entire facility devoted to material testing, all kinds of materials, all kinds of alloy compositions and chemistries that come up with the next generation of materials for mission critical applications. It's truly cutting edge. People just think, steel is steel. No, it is definitely constantly being evolved.
Yeah.
Even the melt shops that are making the ingots for us, they're constantly being challenged with coming up with different grades as well. Bigger. So when I talked earlier about converting multiple pieces into a single piece, the piece gets bigger. And so when the piece gets bigger, things get heavier, melting gets more complicated. So those guys are working on it too. It's not stagnant.
So there's always an innovative evolution in the materials, it sounds like.
Yep. 100%.
Right. Well, I know Scott Forge does a lot of things, as we talked about earlier. Maybe we can spend some time talking about some of those manufacturing processes. Forging and casting were two of those areas. Help us better understand exactly.
There's a forging over a casting, and there's pretty much basically two reasons that a casting makes more sense for most or some designs.
Yeah.
For casting, one, the metal is very easily formed into a near net shape, right? So when we're making subplate mounted valve bodies, those can have complex paths through them, and a casting, casting makes sense there. And there's usually a lot of them involved. And so my second point is it can be done at relatively low cost compared to other metal forming, shaping methods. So for those things, it makes sense for sure. Forgings consolidate inclusions and porosity that castings are known for. And that makes material grains aligned with stress directions. It can get deep when we start talking about metallurgy and stuff like that. But
Yeah.
Larger manifolds, high pressure piping, for example, when those get forged, all the grains are aligned in the stress direction. So that's why forgings are preferred for that high critical application.
Right. So they're really two different kinds of processes. And
Yes.
it results in a different kind of, it sounds like to me, it's like different strength categories you get from both.
Yeah, absolutely.
Great. Well, so they're not interchangeable, in other words. People should, when should people be looking at either casting or forging?
Yeah, great question. So just like material grades, there's pros and cons for each, right?
Yeah.
So if you got a relatively low stress application, you got a large quantity of parts, a casting might make sense for that. It's usually pretty cheap too. If you got mission critical stuff or critical application, high stress, high force, and having an inclusion in the material must be kept to a minimum, maybe the forging comes in and makes more sense. And even like the shape of the product as well. So if there's like a really complex geometry, something like that, kind of low stress casting might be better. I will say, as a forge shop, we do convert a lot of people's what they think they want a casting into a forging, and we don't hear back from them, which is good news.
No complaints, right?
Right.
Well, that's interesting that they come to you for casting and no, you really need this thing to be forged. That's interesting.
Right.
Yeah.
Yep. And we have some unique metal shaping capabilities to get it more near net shape. Not maybe as close as the casting can, but we try our best to get closer.
Yeah, that's great.
Yeah.
So do you have any closing thoughts, Ehren, to share with our listeners? Tell us more about what you guys are working on.
Yeah, absolutely. So I'd just like to sum up our maybe discussion today and note that, material selection is not a one size fits all discipline. There are many different types, shapes, kinds. They all have their trade-offs to consider for any application. Ton of grades out there, and being educated on all these different materials and grades is imperative to best engineer a machine product in any industry, at a decent price, right? One could argue that there's more engineering that goes into the material selection process for a given project than the mechanics of the machine itself.
Yeah.
So again, I greatly appreciate the opportunity to talk. And if anyone has any questions, please feel free to reach out.
Well, we'll definitely put a link to your contact information in the show notes for this episode. And of course, we would encourage any of our listeners who want to learn more or get more engaged to reach out to you.
Awesome. I'm here. I'm ready.
All right. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Ehren Polheber, who has been my guest on the episode. Again, if you want to connect with him, check the show notes for the episode. You'll find a link to his email and contact information there. And remember, if you like our podcast, and we hope you do, please follow us on LinkedIn. You'll find us there at the National Fluid Power Association. Get all kinds of updates on the show and other activities of our organization. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly do want to hear from our listeners about the kind of topics you'd like to hear discussed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.